Welcome to qnawire.
In this exercise, we have a particle in a box that has rigid walls located at x equals 0 and x equals L. Now this box has these two walls here, and the force that is exerted over a particle that's traveling between these two walls by the wall is infinite, but the time it takes for the force to be exerted is equal to 0. The force is instantaneous. Even though the force is infinite and delta t is equal to 0, the impulse that is defined by F times delta t is different from 0. And our goal is to calculate what is this impulse. Now remember that another way to write the impulse, you can write it either as F delta t or as delta p, that is the variation in the momentum of the particle. So basically, in order to calculate the impulse, I'm going to calculate delta p. In order to calculate delta p, I'm first going to remember how to express the momentum for a free particle in quantum mechanics. So the momentum is equal to h bar times k, where k, in our case, is equal to n pi divided by L. Okay, this is the quantized wave number k for a particle in a box. Okay, just remember that psi, the wave function for a particle in a box, is equal to a normalization constant a times the sine of k x, where k is given by this formula that I just wrote. Okay, so the momentum of the particle, the magnitude of the momentum, is equal to h bar n pi divided by L, which is the same as h n divided by 2L. Now notice that when the particle is moving to the left, the momentum of the particle is also to the left. So if I set up a coordinate system such that the x-axis is pointing to the right, the momentum, which I'm going to call the initial momentum pi, is equal to minus hn divided by 2L in the I direction. After the particle bounces off the wall, the final momentum has the same magnitude, but an opposite direction. So the final momentum is hn divided by 2Li. So the impulse, the magnitude of the impulse, is just a variation of the momentum, and this is equal to hn divided by L. Okay, this is the impulse for the x equals 0 wall. This is the magnitude of the impulse. And for the x equals L wall, I'm going to go back to the picture here. So I have a particle that's moving to the right, so the initial momentum. Now, the initial momentum is equal to hn divided by 2L I, while the final momentum is minus hn divided by 2L I. So the impulse I is the variation, which is minus hn divided by 2L minus hn divided by 2L, which means that the impulse is minus hn divided by L. Okay, also in the x direction, but pointing to the opposite, pointing to the negative x direction. So this is for x equals L wall. This concludes our exercise.